Started today with a quick announcement that has nothing to do with this class, but has everything to do with a big part of many of your experiences here at GCC. If you are a student who gets financial aid, there is a very important thing happening right this afternoon, right after our class, right here at GCC. There's a group of folks associated with the Massachusetts State Legislature who are convening at a bunch of different places around the state to try to hear students' inputs on financial aid and the policies and rules, and there's things that are changing and they want your input. And so right after class, if you head down to the dining commons, it starts at 2 o'clock, we finish at 2:15, but if you feel like going down there and making your voice heard, this would be a great opportunity to do so. Even if you don't have anything you really want to say, it might be a good thing to go listen to, okay? If you are on financial aid, this might affect you, so maybe check it out. Okay, we'll take our quick look at the calendar. So today we have our second day on cryptography. I promised you that the methods we talk about today are more complex than the methods we talked about on our intro to cryptography day last class. The voting project was due. I have returned the voting project to everybody that has handed it to me. If you lost any points anywhere on the voting project, make sure you figure out exactly what went wrong before the test. The whole point of the timing of this project was so that if you missed the boat on any piece of voting, that you'd have this feedback in time for the test, okay? So ask me, ask in the studio, go see peer tutoring, lots of places to answer those questions. Speaking of the test, when is the test? Monday, 1 week from today is the test. So today's our last day of new material. Our review day is coming up this Wednesday, and then the test is 1 week from today. It is definitely not too early to start studying for that test. Sunday night might be too late to start studying for that test. Speaking of the test, I mentioned that we wanted to open to page 53. This is actually not where we start today, but it is where there are some resources that I want to point out in case you want to get a jump start on studying for the test. You will find a study guide which has a list of things that I'd like you to be able to do in order to succeed on that test. And on the very next page, you will find sample test problems. I know that many of you are very busy and you have a lot of time commitments in addition to your studies here. And so I don't want to say that everybody's going to have time to like do every homework problem again or read every section of the book again or do lots and lots of everything again. But if you do nothing else, at least do these sample test problems, okay? There's an answer key to the sample test problems. They follow a few pages later, but I also want to highlight that if you go to YouTube and you type in a phrase like that, you will find a video of me going through each one of these sample test problems, okay? Yes, Chad.
They can go through Moodle and the playlist is right there. That's why I finished the class and your playlist.
Yeah, thank you. There's a playlist for all the YouTube videos up on Moodle as well. Thanks, Chad. This is page 54 towards the top. Second paragraph. Yep, good. Questions on the resources? Okay, then let's go back just a few pages to the beginning of the next section of material, which is right here. So page 47 is where we officially start. 47. Okay, let's see. So we already talked about number 0 here, which just says if you made any mistakes on the project, figure out what happened before the test. We'll go to Casey for number 1. Thank you. And just like last class, these materials were adapted with permission from the same guy, James Hamblin. We'll go to Griffin for number 2. Okay, so let's answer the first question. That's pretty straightforward. If it's 11 now, 5 hours from now, it will be 4 o'clock, so that's fine. 50 hours is a little bit tougher. What time will it be in 50 hours? Ed? Ed says 1, Casey says 1. Other votes? 1 feels okay. Ed, how'd you get it? Okay, so Ed did something really nice here. He said, wait a minute, I know that 48 hours is just 2 full days. And if you tell me what time is it 2 days from now, well, it's exactly the same time 2 days from now. So we can ignore those. So really this is just saying 2 hours from now. And 2 hours from now is 1 o'clock. So that's good. So then the final answer to this one is 1 o'clock. All right, number 3, Stephen. Okay, so I have a son, he's 2 years old. If I wrote down 11 plus 5 equals 4, like it would scar him for life, right? He can't handle that at the moment, right? Scars Ida for life. So, but 11 plus 5 equals 4 is perfectly reasonable as long as we're looking at the clock, right? That's what you guys said. It's 11 o'clock, 5 hours from now, it's 4. So there's this whole branch of arithmetic that we use without even thinking about it as being anything special when we think about time. And that's going to be important for us today when we do our new cryptography method. So let's keep going. Stephen, can you continue? Notation. Yeah, and so the way that we write that previous sentence isn't just 11 plus 5 equals 4, which would be very confusing, but rather instead of an equal sign with 2 lines, we'll draw an equal sign with 3. And then we'll put this thing over here, mod. It stands for modulus, and we don't need to worry about it, but it's just telling you how many hours there are on the clock. 12 in this case. So that mod 12 is our way of saying use the clock and just count around on the clock. So you'll never get anything bigger than 12, right? You just wrap around and start over again at 1. So the mod is modulus, and it captures the fact we're working on a clock, which has 12 numbers on it. Okay, let's try number 4 in your groups. 7 plus 23 is equal to something, mod 12. So check in with your neighbors as you fill in the blank there. Okay, what do we have for that one? 6. How much is 7 plus 23 normally? Is 30. And then we'll say, okay, 30 on a clock doesn't make sense, so you can go around 12 or 24, and then it's 6 left over, right? So 30, and then you can subtract off the 2 times around the clock, and we get 6 mod 12. Piece of cake. Let's go to number 5 here. Lila? Okay, so we've seen a few numbers pop up as answers on the clock. We saw 1 o'clock pop up. We saw 5 o'clock pop up. Here's 6 o'clock popping up. Let's just list all of them. There's no like half hours or anything like that. It's just the numbers on the clock. So what's the smallest number we see? It's 1, and then 2, and then all the way up until, yeah, I'm going to write 11 and then 12. So 12 different possible answers when we're doing clock arithmetic. But the fact is, mathematicians have a really good reason for renaming one of these, and it's that biggest one. We're not going to call it 12, but we are going to bring in a number that is going to be very useful to us. If I cross off 12 here and bring it in on the other side, what time is it? 0. If we follow that pattern, just go in the other direction, and it wouldn't be terribly confusing, would it, if I just crossed off the 12 and called it 0? Like, it would be weird to say like 015 instead of 1215, but it would be easy enough to figure out what we meant, right? Okay, 0 is a really important number. It's more important to us than 12. So we're just going to rename the 12, call it a 0. Other than that, it's just as we are on the clock. Yeah, it's like military time, right? 0 through 24. Great. Okay, next one is another fill in the blank. 4 plus 8 is equal to something mod 12. Yeah, so what's your gut reaction? Forgetting what we just did is 12. But now bring in what we just did. 12 doesn't exist. It is now 0. So if you see a 12, make it a 0. Great. Okay, 7, Kate. Okay, keep going, please. Okay, so let's try this one. 7 minus 16, forget the funny clock business. What is 7 minus 16? is -9. Yes, that's ordinary. -9 doesn't exist on the clock. What is -9 really? It's 3. And if you don't believe it, I mean, there's a nice little shortcut, but if you just start at 0 at 12 and you walk around 9 hours backwards, right, counterclockwise, what number do you land on? Land on the 3. So it's 3, but the easy way is to just say, well, I can just add 12 to any number I want, and that will turn it into something that's equivalent to the number that we had to start. You can add or subtract as many 12s as you need to anytime. So this one is just 3. Okay, moving on to 8. Brandon. Okay, so instead of having 1 through 12, but really 0 through 11, imagine having all the letters of the alphabet, so they'll be smushed in there. So how many do we have? How many letters do we have? We have 26. Now we're never going to use that big number, 26. We're going to instead call it 0. So we're going to have 0 to 25, but we have 26 as our modulus, which means all the numbers are going to be from 0 up to 25. And here in number 9, it says we're just going to start with A, which we'll call 0. That's at the top. And then the next one is B. That's 1. And then C is 2, all the way around to Z, which is what number? Z is 25. A is our 0. Z is the last number we have, the biggest number we have, which is 25. 0 to 25. J is included. Yeah, we only, poor J got the short end of the stick last class, but we only treat J differently in that one method with the square. Okay, so there's a table on, it's like page 5 or something like that, which I've put here, but you'll be able to use it on the test. But this table right here at the top is just the association we just said. 0 is A, 1 is B, 2 is C, all the way up to Z, which is number 25. To be clear, how many numbers are in that list? 26. It's mod 26, but all we've done is gotten rid of the 26 and renamed it 0. Okay, moving on to number 10, Mary. Okay, so we've already done this problem. We did this problem last class, and we're going to get the same answer we got last class, but we're going to do it in a different way, and this different way is going to lead to this new method called the Vigenère method. So just write the word daybreak. That's what we're trying to encode. And the next thing to do is look up at that handy table there and replace every letter with the number. So what number is D? It's 3. What number is A? 0. So very carefully, fill in the rest of that second row. Double check each of your answers with your neighbor when you're done, and then we'll come back together. Okay, next thing we need is something called a keyword. Now for Caesar, we didn't have a keyword. It was just go 3 letters forward in the alphabet. That's what Caesar was every single time. So what I'm going to do is I'm going to grab the letter up here that corresponds to the number 3 because we were going 3 places forward, and that letter is D. And so I'm going to do something very strange. I'm going to write D below each of these letters that we've already written. So just write a bunch of Ds. No, I'm putting a D not because that's what the word starts with, but I'm putting a D because the definition of Caesar is that we add 3, and 3 happens to be the letter D. So it'll make more sense as we fill in this next row. We're just going to put the number. What is the number for each of these Ds? It's 3. So we're just going to put a whole slew of 3s here. And so Ida, the reason we put that D is because Caesar, by definition, is go 3 forward. And that's the only reason it's a D. Okay, in this next row, the directions here say add or subtract. And then it says 26. That 26 is there because I copied and pasted incorrectly. Cross off the 26. It should just say add or subtract. And that's going to be true in every one of these tables because as soon as I made one table, I copied and pasted it a million times. So they should all just say add or subtract. Okay, so it's not clear which one we're supposed to do, so take my word for it. Right now, we're going to add these numbers up. That's all we do. So we're going to add just the numbers. So the blue 3 plus the red 3 gives me 6. Adding those numbers up. Then we add the 0 and the 3 and get 3. Go ahead and fill in the rest of these very carefully. We make one mistake and all of a sudden our message gets completely mixed up. If you have more than 26, you just write it. So what's this next number? 27. And Alicia's got an idea here that we've got a problem. Because 27 doesn't exist, but we'll handle it. So fill in the rest, check with your neighbors. Okay. Now, most of these numbers are fine because they exist in our chart, but there's one that's no good. Which one? 27. 27 doesn't exist here. Why is 27 okay? We are, but when the final product here is going to be letters. So we need to ultimately get to letters. And the reason 27 is no good is because it doesn't have a letter here. So again, we're doing mod 26. And when we were on the clock, we were allowed to add or subtract 12 anytime, and it wouldn't change anything, right? 12 hours from now, this clock will look exactly the same. So you can add or subtract 12 on the clock. You can add or subtract 26. That's how many there are up here, and it won't change anything. So what are we going to do with this 27? We're going to subtract 26. And when we subtract 26, we get 1. And 1 is in our chart, so I'm happy with 1. So what we just did there was this mod 26 business. And so you can make a little note to yourself if you want to. It says at this stage, you add or subtract 26 as needed. Add or subtract 26 as needed. Every other number is fine. Just copy them straight down. And what do you think is the last step now that we have our numbers? And we're going to go back to letters. So 6 in the chart is G. And go ahead and fill in the rest of those with the letters. Check with your neighbors. You should get some gobbledygook, but you should all get the same gobbledygook. Okay, did we all get this? G, D, B, E, U, H, D, N. All right, so that is the encoded version of Daybreak. And it's exactly the same as we got last class. We did Daybreak and we got exactly that. If you don't trust me, you can just go back a few days. But it's no surprise. In fact, what we just did was spend a long time doing an easy problem. Because again, remember the key for Caesar is you just go 3 steps forward. So for example, when we had the letter B, you would take 1, 2, 3 steps forward and it would become E. Did the B become an E? Yeah, B became E, right? By going 3 steps forward. We could look at one more. How about this R? If you go 3 steps forward from R, just looking up there, lands on U. Did the R become a U? Yes, this took a long time, a lot longer than it should have if we just looked up there and went 3 steps forward. But like I said, this is going to someplace more general than the Caesar cipher. So we'll use this and be able to do new problems that we couldn't do before. Okay, so 11, who's our reader now? Is it Ed? Yeah, and that's a really important point. It's 26 that we are adding and subtracting, even though 25 is our new biggest number. So we got to keep that clear. So when we encoded, we had to add the D. We had to add 3 to everything, right? When we decode using Caesar, we're just going to subtract. So let's come down here. Now I've made a change. Can you guys cross off the gobbledygook that's up there on your page and instead put this thing that's here in blue, IXCC. Okay, what goes in the first row is that stuff. So put that in there. You can ignore spaces when you put it in here. And you write them, yeah, just as you see them. Yeah, it's a good question. So Chad had asked about the J, and Ida is asking about, well, can you duplicate letters? Because when we did our grid the other day, remember that square that we filled in? We weren't allowed to duplicate letters. So it's going to be part of your job in studying for this test to really keep these methods separate. because the rules that we had for the bifid, the square, are kind of completely different from the rules for this one. Okay, now that we've got the letters, what's next? Is the numbers. So we just use that chart way up there at the top, and we fill in the corresponding numbers for each of these. Again, check with your neighbors when you're done. Make sure everybody's got the same thing. One thing that I noticed, Damien was able to speed through this because, at least what I saw, anytime he had a letter that was repeated somewhere, he would fill that number in right away. So as soon as he saw that C was 2, he changed all the C's into 2s. That might be a little shortcut. Is that nice? Yeah, give yourself a pat on the back. Excellent. Okay, the keyword. We're still doing Caesar. This gobbledygook was made from Caesar, so it's still different by 3. So what's our letter that's always 3? Is D. So all of these things become D's. It's kind of silly. And by the way, I'm never going to ask you to do Caesar this way. Like I said, we're heading to a bigger and better method, or a more general method here. But I'm trying to tie it into something that we know how it works, and hopefully we'll buy that this is just a different way to do that same thing. All the D's become 3's. And now how do we decode? We subtract. It's just going the other direction, right? Somebody added 3's to all of them. We need to subtract 3's. So maybe I'll highlight here. When we are decoding, we are subtracting. So that's exactly what we're going to do here. So very carefully subtract all those 3's. Did any surprising numbers pop up? Negatives. We got to handle those. That's right. Some of you guys have got this figured out. Handle the negatives the same way we dealt with the clock arithmetic. Okay, so double check that I've got those right. And any number that's in your table right now, you can copy. So I'm quite happy with 5 and 20, 22 and 20. Those are all fine. Those come straight down. But the problem ones, we need to get them into the table. And negatives aren't in the table. So what do we do with them? We add 26. We're allowed to add or subtract 26 anytime we want. So we are going to add 26 to all those negative numbers very carefully. Okay, so very carefully add 26 to all those numbers. And then finally, you just got to translate to the letters. And once you see the answer, don't give it away. It's part of the fun, right? Trust me, it's going to be worth it. Somebody got it? Don't say it out loud. Wasn't it worth it, Casey? Alicia, it was worth it, right? That was awesome. Evan likes it. Any questions on the adding 26 part? It's trickier. We're just, as a species, we are just not really great at negative numbers. So this direction is harder than the one we did up above. Chad. Let's see. So we had a negative, let's look at the -2. All right, so what would you do if you saw a -2? All right, so does that seem reasonable if we go 2, 1, 0, and then we'll cycle back around -1, -2, just continuing? Was Y the right answer for that one? Yeah, absolutely. Good. Okay, so it's kind of silly, but look, I needed to come up with an example that had negatives in it, which meant I had to get letters that were where to start with. I had to get them near the end of the alphabet so it would wrap around when we added 3. Okay, so Z's and Y's, that's all right. Okay, so like I said, I'll never ask you to do Caesar either direction that way, but the good news is we're now going to vacate Caesar, but use everything that we just saw worked in that table with this new method, the Vigenère cipher. Okay, 12, we're up to Evan. Okay, so same start as before. Write the word raccoon. And then what do? We get the numbers. So check with your neighbors again, make sure the numbers are good. Okay, and what did we have for Caesar in that next row? It was all D's. Well, that was boring and very easy to decode if you just add 3 to every letter. But now we're going to add a different amount to the different letters. We're going to add the word ape. So copy the word ape, A-P-E, and then we repeat, A-P-E, and then we put an A. You just keep writing the word ape until you've run out of message to encode, right? Yeah. That's right. So fill in the numbers, and then this is an encode. I'm just going to start highlighting. Encode means add. So let's. What you are going to add is the 2 numbers that you have right on top of each other. Yeah. So see if you can get all the way to the end of this one and check in with your neighbors along the way. Okay, so Casey asks a real good question here. What, are we adding or are we subtracting? Well, there's actually 2 different things that we have to worry about. Alicia, could you just step to the right as you write? Step a little bit to the right. There we go. Super. So first thing we have to do is either add or subtract once you have your 2 sets of numbers. That decision is entirely based on whether you're encoding or decoding. I've highlighted here in blue, encode always means add in that row. And so again, that might be something worth noting. It's kind of written up above, but if you are encoding, you are adding the 2 numbers. If you are decoding, you are subtracting the 2 numbers. It's just a hard and fast rule. That's how this system works. But then separately, thank you, Alicia, separately, once you get to a number that's problematic, like 29, you need to fix it. How do you fix 29? Is you subtract 26. So Casey says, do you add or subtract? In this problem, it was both. First, we added because we were encoding. And then we subtracted because we had a number that was too big. So it's both. What happened up here? First thing, was this an add or a subtract? It was decode, so we subtracted. But then we had some problem numbers, like -1 and -2. And what did we do with those? We added. You're always doing one of each. If you subtract first, you're going to have to add at the end, add 26. It's another question. Some people are stuck on the 25 thing. It's always 26. So if you subtract first, you're going to add second. If you add first, you'll subtract second. You have no choice. I know this is America and we're free, but you have no choice here, right? If you are encoding, you are adding. If you are decoding, you are subtracting. Can't get away from that. Okay, let's take a look here at 13. I think our next reader, did we already go around that table? We did. Aileen? Okay, so for example, the letter O and then the letter O. Did they both become the same thing? No. One became a D, one became an S. That makes it a lot tougher for the person trying to crack our message. Right? This is a good thing that it's not a substitution cipher. Next page. Okay, 14. We're going to decode using Visionaire. Visionaire is just this repeated keyword. Okay, so here's the message. Is this TMI nonsense? Or TIM nonsense. It's written there, and the keyword is tricks, like that cereal. So, what do we do first? Write that nonsense phrase. And then you're going to put in the numbers, but I'm going to pause on that. I just want to give you the final instructions, and then you can do the whole process in your groups. What goes in the keyword row? tricks. So we put TRIX and then tricks again. And then TR. TR. Just keep writing it until you don't need to write it anymore. And when we get down here to this question about adding or subtracting, which one is it for this decode problem? It is subtract. It's the other direction. Okay, so work through the whole way, check in with your neighbors, and see if you can get to the secret message. Again, don't reveal it once you get it. Okay, Ed came up with a nice way to help us remember that when we're decoding, we should be subtracting. Ed? Good. So Ed is now associating the word decode with decrease. And decrease makes us think subtract. There? So decode, you are decreasing. I think that's good. I asked him to come up with one cutesy thing for the other direction, but he said, hey, if you know one, then the other one is just what's left over. You don't need another one. Encode, enlarge. Super. Okay, so Nicole is wrapping up there. Let's move on to number 15, and our reader now is Damien.
However, since the keyword repeated, it's possible to modify the process.
Okay, so we need something stronger even than this very complex method. Barb, 16. Okay, so at the beginning it's going to look exactly the same. We're going to use this new thing called auto key. Bruce Willis is the message, so let's write his name across the top. And then let's see if we can, as quick as we can, get these numbers in here. Please. Thank you. Okay, next thing we need is our keyword. What is the keyword in this problem? It's tux, T-U-X. So we're going to write T-U-X in the next line, T-U-X. Now, if we were doing Visionaire, what would we write after T-U-X? Well, we would just keep writing tux. But it turns out that's crackable. If you just keep using the same keyword, even though it was this complicated method, it's crackable. So we're going to come up with something that is harder to crack. We're going to pause on the rest of the keywords. So it's a little bit uncomfortable that it's like not filled in yet, but let's just do what we can over here with tux. So T, U, and X become numbers. What are they? 19, 20, 23. Okay, this is an encode. So we're going to enlarge. So we're going to add. And again, apologies for all this add or subtract 26. It's just add or subtract. No 26 until the next line. Okay. Any number that's too big needs to be cut down to size. We'll copy that 20. What are we doing to cut down the other numbers? Subtracting how much? 26, not 25. Always 26. So carefully subtract 26. I don't know how to do my subtraction here. 26, 13. Somebody help me out here. 17, 26. That makes sense. Thank you. Okay, and now we're going to fill in the phrase. So it'll be gobbledygook, but we can translate back to letters. So what do we get down here? 20 is U, L, and then R. Okay, U-L-R, no problem. So here's the trick. Is it the next part of that keyword, instead of being tux, is ULR. So we're going to copy that thing right up here. ULR. Just once. No repeating, because repeating makes it easier to crack.
So we just do the first.
So you do whatever you can, and then you bring over what you've got as the next part of the keyword.
Yeah.
And then we're going to go straight down
Do the same.
and get 3 new letters, and we're going to bring that over. Well, I told you it was complicated.
Okay, so you will learn.
The nice thing is ULR, you already know the numbers for, so that's easy to copy. Add or subtract here? Add, so we got 22, 15, and 39. 22, 15, those are happy. 39 needs to come down to size. So subtract 26, get 13. One vote for WPN. Couple more votes. That's the next part of the keyword. It's brutal, isn't it? But the point is to make it hard to decrypt, hard to decode. We're just going to use whatever letters we need. Yeah, the first 2 in this case. Any questions on the WPN? Like if we got to WPN, then it's just more of the same to finish this problem out. That's right. You use the letters in the order that they appear. So yes, the first ones are the ones you want.
Zero.
26 is 0. That's the one that gets renamed. E-A-Y, is that right? Yeah, and then you just use the E and the A. Yeah, tricky part at the end, you just grab the letters in the order that they appear. So just the E and the A. What's that?
I'm just talking to myself.
Whoops. What's the danger if you make an error early on in this problem?
Whole thing out.
Everything, right? It's just this cascade. So the moral is don't make a mistake. That's my advice. E and then A come up here, circle them, and then we'll get our last one. So what are these? 5, 4, and 0? And then 12 and 18. Those are both happy. MS. Super. ULRWPNEAYMS. So this is the hardest method that we're going to learn. It's the last method we're learning. What's the only other thing we have to talk about with this method? Is the decoding, which is going to be just as brutal as the encoding. Maybe even more brutal. Oh, one quick thing. The word auto means self, right? Auto means self. The key is in the phrase itself. That's why we call it auto key. It is its own key. Okay, 19. Here we go. We're going to decode this message using auto key. Keyword is Patriots. We had a big win last night, right? Barely squeaked by, but a win is a win. Okay, so the message is this thing with H's and stuff. So we're going to do the first part of this together, and then you guys will go off in your groups and see if you can get the rest of it. What goes in the first row? All that weird stuff, H-U-I-V. And then once you've got all that weird stuff in there, see if you can get the numbers. Again, this is a problem where if you make a mistake early on. It trickles everywhere, so you really want to check with your neighbors before you go too far in any of the steps. Okay, so everybody have the numbers? Don't move on until you confirm those numbers. Any mistake trickles all the way through. Okay, what is the beginning of the keyword? It's patriots. It's a longer keyword than we had before, which means we'll be able to do more of the problem in each turn. So patriots goes here. What's the name of the method where I would write another copy of the word patriots? That's a Visia something, right? All right, so that was the method we saw, but this is auto key. That tells us that we need to pause here and do what we can before we fill in the rest of the keyword. Okay, so the patriots translates to all the numbers. And this problem, is it an addition or a subtraction? Subtraction. We are decoding, so we are decreasing. So we subtract first. We subtract first, yes. Okay, so very carefully with those negative numbers. Once you have your numbers, what do you do with the negatives? Add 26, very carefully.